Hello, all, and welcome to Artham Academy, aspiring leaders in innovation and technology. In today's video, we would talk about petrol and diesel cycles, and also we would see petrol and diesel engines. We would see the key differences, what separates petrol and diesel engine, and in what scenarios are these two engines are beneficial. So let's get started.
So what is an engine? Engine is basically a powerhouse of a machinery. It gives us the required amount of power to run the machinery. Through various processes, it converts one form of energy to other form of energy. For example, in an engine which is operated by petrol, the petroleum energy is first combusted and then it's converted into chemical energy, and using that it is converted into a rotating motion. And that is how the conversion of energy takes place at various levels. It can either be electric, it can either be diesel. So there are various options that are coming up in this recent times with the introduction of new cars like Tesla. They operate on electricity. So in that also the electrical energy is converted into the mechanical energy. So the rotation of the wheels could happen and your cars could move ahead, or any engine or any kind of machinery could operate, because there are various number of operations that are happening in a manufacturing industry, and for that engine is required. Internal combustion engines are most common and we generally talk about them, but it is not that these are the only engines. There are ramjet engines, scramjet engines, there are jet engines, and there are external combustion engines. So there are a numerous variety of engines available in the market, but internal combustion engines are very popular, and that's why we are going to talk related to that. Also, these engines are used in automobiles, aircrafts, naval vessels. For example, in the ships, in big ships, you would have seen big connecting rods and combustion chambers, and that's how the big ships operate, usually on diesel. But with the advancement, now uranium and the nuclear submarines and nuclear naval vessels are used, so that we do not have to depend on the amount of fossil fuels. Now let's talk about petrol engine. Seeing at the cycle, you might find it weird, but this is how the petrol engine operates. So in the given figure, it is already mentioned what each processes means. 1 to 2 is isentropic compression, 2 to 3 is constant volume combustion, 3 to 4 is isentropic expansion, and 4 to 1 is constant volume heat rejection. When we operate from 1 to 2, the top dead center moves towards the bottom dead center. After that, the Q input takes place. Here, using the Q input, we enter the heat that happens with the help of spark plugs, which ignite the mixture of air and petrol, and this is how the combustion takes place. After that, it has done combustion, so there is enormous amount of pressure is generated, which again pushes back the entire top dead center back to its original place, and that's what happens when we reach at point 4. After reaching at point 4, Q out happens because we release all those burnt exhaust gases so that it could be used. We release all the burnt exhaust gases so that we can continue in our cycle. Now let's talk about some of the features of petrol engine. In the petrol engine, air and fuel is mixed before compression in the carburetor. Carburetor is a mixing chamber kind of, where the fuel and air is mixed in the appropriate ratio. When the air quantity is more, the mixture is called a lean mixture, and their ratio is equal. They are called exact mixture. And when the fuel quantity is more, it is called rich mixture. In the petrol engine, the compression ratios are usually low, and it is based on the Otto cycle. So whatever cycle I have explained you now, it is called Otto cycle, based on the inventor who invented it. Ignition happens with the spark, which is electrically generated. So here air and fuel is mixed beforehand and it's sent into the combustion chamber. So here spark is given so that ignition can happen, combustion can happen, so that it can push the piston and it can rotate. And that is how the strokes are generated, and that is how the mechanism of automobile operates. Strokes are operated with the help of cams or electronically. At what amount of time, what stroke has to be given. Like 1 to 2 is called suction stroke, 2 to 3 is called combustion stroke, 3 to 4 is called power stroke, and 4 to 1 is called exhaust stroke. So the timing has to be defined with the help of cams. Now let's talk about diesel engine. So the diesel engine is named after its inventor Rudolf Diesel. As we can see in this PV diagram, this looks completely different. In this, the compression happens from 1 to 2, and then a horizontal line 2 to 3 is made, in which the heat is input. The major difference between is that in the previous cycle it was vertical, in this it is horizontal. It means that the process doesn't happen at constant volume but at constant pressure. So for that case here fuel is injected with the help of fuel injector and atomizer so that proper combustion could take place. And here ignition takes place because of high compressed air which is at high temperature. And when the sufficient pressure and temperature is generated, from point 3 to 4 happens the expansion. And as always 4 to 1 is the exhaust stroke in which the burnt gas is removed. And this is how the whole cycle operates. But this is an ideal cycle. So let's talk about some of its features, which is air is compressed separately. Fuel injector and atomizer is used to disperse the fuel. High compression ratios are possible. Strokes are operated same using cams and electronically, and named CI engine because of compression ignition engine. Compression ignition engine means that we are compressing the air, and then after the air is being compressed, the heat is generated. It gives sufficient temperature to burn the fuel which is being sprinkled using the fuel injector. Let us talk about the summary. What are the major differences? So engine cycle, it's diesel and petrol. Ignition. In the diesel, it happens because of the hot compressed air. In petrols, it happens because of spark plug and air fuel mixture. Power production is usually high in diesel. That's why it's used in high naval vessels and diesel submarines and also in trucks. But in petrol, the power production is relatively low. The fuel that is used in the diesel cycle is of low volatile, and in petrol, it is of high volatility. So accordingly, the fuel is selected. Now talking about the vehicles, obviously if the power production is high, it is used for the heavy machinery, that is of cranes and the construction machines that are going on. But for petrol, it is used for small carrier automobiles and vehicles. Fuel consumption is generally low in the diesel engine, but it is a lot in petrol engine as compared to the diesel engine. But maintenance and initial cost is very high in the diesel engine, whereas in petrol engine it's relatively low. So this is how we can segregate diesel and petrol engines in the tabular manner. I hope to see you all in our next video. Till then, keep learning, keep growing.
That's all for today. We would see you in next lecture. For any information, you can contact the below given details and feel free to reach to us. Thank you.